The last non-parametric that we're going to look into is the Kruskal-Wallis test. The Kruskal-Wallis test, a parametric counterpart, is something that we have not yet encountered, but we're going to encounter it in future lessons. So, an extension of the Wilcoxon rank sum technique is the Kruskal-Wallis test. The Kruskal-Wallis test compares more than 2 independent samples. The data must be at least ordinal and should be randomly selected from the respective populations. So, our null hypothesis for the Kruskal-Wallis test is that all the population medians are equal. So, this time, we're not comparing just 2, but 3 or more independent. May I repeat that? Independent samples. As long as one of them, for example, say this is group 1 and this is group 2, 3, and 4. This 3 might be equal, but if 4 will not be equal to 3, and obviously not equal to 2 and 1, then we're already rejecting the null hypothesis that all should be equal. It can also be the fact that these 2 are equal, but these 2 are not equal. So, we are going to reject our null hypothesis on that. So now, let's have an example of the Kruskal-Wallis test. So each of 3 aerospace companies has randomly selected a group of technical staff workers to participate in the training conference sponsored by a supplier firm. The 3 companies have set 6, 5, and 7 employees respectively. At the beginning of the session, a preliminary test is given and the scores are shown below. At 0.05 level of significance can be concluded that the median scores for the 3 population of technical staff workers could be the same. So let's now head to Excel for this. Alright, so we have our data here already. So, right. Yeah, the 3 firms. Correct. So now, let's first write our HO and HA because we're dealing with non-parametric. So our HO and HA, since there are 3 groups, we can say that the median of firm 1 is equal to the median of firm 2 is also equal to the median of firm 3. So there. We're now using sample median. And then the HA, not all the medians are equal. Now, we're not going to go into specifics just yet of which samples will not be equal. So, that would be enough for our HO and HA. And since we have more than 2 groups, there are no more directions to look into. So now we go to our non-parametric test and comparison of K samples. So these are our samples. We just select all of them because as you can see, it's just one sample. 1 column per sample. That's correct. 1 sample, 1 sample, 1 sample. And this is now the Kruskal-Wallis test. So we have column labeled as such. So there you go. Alright, so let's just, for options here, let's just check our significance level. 0.05, 0.05. Now, if we would like to have multiple pairwise comparisons, we would like to compare which are different, then we can check this. Then we can select which of this we're going to use. Sorry. I missed. So there you go. We're just going to have this and then we'll just check this out. Yeah, so we're going to have the compared categories in this order. We'll have this correction to the significance level just in case. We're going to have really different groups. So when everything is okay, for the missing data, let's just click ignore because as you can see, they're not equal. So just ignore the missing data. And outputs, then we're okay, we'll click okay and then do this. It's a little long because we have equal groups. There you go. So for our summary statistics, we have this one here. Just remove them. And here. So first, here is the actual Kruskal-Wallis test. So we now have steps 2 and 3. So for step 4, the p-value of 0.016 is compared to 0.05 is smaller. Hence, we reject HO. With that, our conclusion is that there is sufficient evidence to evidence to reject HO. Thus, not all regions are equal. Now, what we had a while ago is, maybe we can pick that up. What we had here, this one here, the multiple pairwise comparison, that is what is usually known as the post-hoc test. This post-hoc test is the one that tells us which exact groups are actually different from each other. So let me just clear this up here. If we go down to the pairwise comparison using Dunn's procedure, Dunn's procedure is one of what we call our post-hoc tests. Post-hoc meaning after the actual test, let's now see which is which. So there. And then we go down to see our p-values. So, with the Bonferroni correct and significance level at 0.0167, we can actually see, let's use a different color, we can actually see that there is a significant difference between the medians of firm 1 and firm 3 here, and well, yes, the same here, firm 1 and firm 3. So, meaning, firm 1 and firm 3 are not equal. Or their medians are statistically different. That's what we say. So there is a significant difference between firm 1 and firm 3. Firm 1 to 2, none. Firm 2 to 3, none. But firm 1 to firm 3, there is. So we can also have that as a conclusion. That, although we can just write it at one color, just write it in a different color for emphasis. Post-hoc test using Dunn's test reveal that the median of group 1 is not equal to the median of group. They are statistically significantly different. So that is how we do Kruskal-Wallis test with an additional of post-hoc test just to determine which of the groups are actually equal or not. So the second example, I'm going to leave that to you as something that you can work on your own. That's one non-parametric test to compare more than two groups, the Kruskal-Wallis test.